This video, I'm going to go over the next section in our transformation unit, 9.3, Perform Reflections. So we are going to review here reflecting various items, lines, or primarily triangles or shapes across a line of reflection. And so sometimes we actually have to graph that line of reflection, so we'll discuss that. I have at the beginning here some vocabulary, so feel free to pause the video to write this down. First of all, just defining a reflection. It is a transformation that uses a line to reflect an image. And then the line of reflection is what the line is called that we reflect a shape or a point or something over. So feel free to pause if you want to jot those down, but we're going to talk more about lines of reflection as well. And then there is also a theorem that was similar to one we saw yesterday called the reflection theorem, and it states that a reflection is an isometry. And remember, the phrase isometry is what it means is it preserves congruence. So if it starts a triangle, it ends a triangle. It's the same shape. It doesn't get larger or smaller. And you can see here in this diagram, M is the line of reflection. So can you see like A reflected over and lands over here? We are going to also see here some similar notation. So do you see how we have the primes right here? So we are still going to use prime to show image, and then we'll have a pre-image. Okay, well, let's take a look at these first couple. We are going to graph reflections in horizontal and vertical lines. So it says here the vertices of ABC are as follows. Graph the reflection of triangle ABC as described. So I want to do all of this on a graph initially, and then we might be able to switch over to just using coordinates. So let's start by plotting the points for A, B, and C. So 2, 4 would be point A. We have point B is at 6, 3. 1, 2, 3, 4, 5, 6. Got A, I've got B, and then C. So go ahead and make your triangle here. Okay, we are trying to reflect over the line, line N, but line N is described by this equation. So we need to be able to graph that equation. So you might recall where that goes, but if you do not recall where it goes, you always can make yourself this T-chart, okay? And so in the T-chart, because the equation says x equals 1, I'm going to write 3 ordered pairs. But they all have to start with 1 because that is a constant value in all of these. Notice there's no y value. So I can just put any number down for y. And so I might just go 0, 1, 2. Now you have 3 ordered pairs you can plot, and you'll start to see your line get drawn. So if we go to plot 1, 0, it'll be right here, 1, 1, and 1, 2. So can you see how it is simply a vertical line? It goes through 1 on the x-axis. So you might remember that, or if you don't remember it, you certainly can make your table. Okay, I'm going to switch over to red here, and let's do A prime, B prime, and C prime. So one way to graph reflections on a graph is to count how far away from your line each point is. So what I mean by that is if you look here at A, it is, let's see, I'm going to do light blue here. I want you to notice that A is 1 unit to the right of the line of reflection. So when I reflect A prime, I have to be the same distance on the other side. So I'm going to put A prime right here. A prime. So it has to be the same distance away on either side. So let's do the same thing on B to B prime. So when I go to count, I'm going to count to the right. It's going 1, 2, 3, 4, 5 units to the right. So B prime has to go 5 units to the left of the line. So I am 1, 2, 3, 4. Right here would be 5 units. That would be B prime. C prime, I'm 2 units to the right, so I will count 2 units to the left. And so when we go to connect, it should look like it reflects over that line. And so sometimes in elementary school, we call these a flip. So can you see how you can just pick the triangle up and flip it over the line? So that is considered a reflection. Okay, so on a graph, that's how we can work through it. So why don't you try number 2 first? Why don't you go ahead and graph, actually letter B, I guess. Go ahead and graph the same triangle and try to reflect over the line y equals 3. So maybe pause the video, see how far you can get, and then resume the video when you either get done or if you feel like you get stuck. Okay, let me get the triangle on here, ABC, B, and then C. Okay, so y equals 3 is going to really go the opposite direction. Now, you could, if you wanted to make this chart, you could. So this time, y is the same value. I can vary x. So 0, 3, 1, 3. Okay, so do you see how this is going to go through the shape, which is fine. It's just going to be a little bit harder to work with. It's going to be a little bit messier. So I'm going to just do the same thing. How far on one side of the line is your point? I want to go the other direction. So since my line of reflection goes through my shape, it's going to flip over like on top of itself on some parts. So for example, I'm going to switch colors so we can see this. So A is 1 unit above the line, so A prime needs to be 1 unit below. B is on the line of reflection. So I'm just going to put a red dot also here. That means that your new point is just on the same spot. It doesn't go up or down. Now C lands below. That means C prime will land 1 above. Now when you go to connect it, having different colors kind of helps. So can you see how it really like flips over on top of itself? And so it's a little bit hard to see, but when your line of reflection goes through your shape, you'll get this kind of strange switching over on top. And that's just kind of normal. That's just the way it looks. Okay, so these two are practicing a reflection over a different line, not necessarily the X or Y axis. Okay, let's move on to the next page. In fact, I think what I'd like to do, I'm gonna make separate videos here so they're not too long. So I'm gonna end the video here, and then the next video will begin on the next page.